his 5 minutes of questions.
Thank you, ma'am. Dr. Fall, last week I was pleased to see that DOE announced the selection of Brookhaven National Laboratory as the site for the construction of the Electron Eon Collider. Eon, it's been eon since I've seen that word. An essential new nuclear physics research facility. That was funny, wasn't it? Yeah. As I mentioned in my opening statement, I feel strongly that these types of DOE National Laboratory user facilities provide American industry and researchers with the tools they need to maintain our leadership in science and develop new materials and technologies. But some of these facilities, like the Advanced Photon Source at Argonne National Lab and the Advanced Light Source at Lawrence Berkeley National Lab, are in need of those critical infrastructure upgrades we talked about. We want them to remain the best in the world. These are upgrades we pushed for with bipartisan infrastructure legislation that passed the House last Congress. In your prepared testimony, you mentioned that the Office of Science is currently working to upgrade both of these facilities. Can you give us a status update on both of those projects and then what new opportunities they might afford American researchers, please, sir?
Yes, I want to be careful. I'll circle back with particular details of dates and so forth, but we've certainly, for both of those, entered into what we call in DOE jargon CD3A, which is advanced procurement for the kinds of long lead time things that we need to buy for these facilities. The magnets, for example, take a long time to build and source, and other materials like that. So the projects have gone through our stage gates and are on track and on budget, and we feel both of those are in good shape. And I do just want to differentiate, as you did, the projects, which are in great shape, from the underlying labs, which we still have some work to do on, and in terms of the infrastructure, like electricity in the case of these synchrotrons, light sources, that needs to be reliable. As you may have heard, Berkeley National Laboratory, because of the fires in California, had to shut down twice at a significant cost to the taxpayer, because you don't just turn off the lights at these laboratories, and it hadn't, as far as the current leadership is aware, it had never shut down before. So twice in the space of just a couple of months. So the reliability, the multiple power sources, that sort of thing is kind of important.
And new opportunities that might afford American researchers?
Oh, absolutely. Every time so there's the science, and then there is the technology and the engineering that goes into building these amazing machines, and that is absolutely, diffuses out from the laboratory complex and has wider applicability. I'll just say something you may know already, that magnetic resonance imaging came out of the magnets for these facilities, right? I mean, the original magnet technology led to the development of magnetic resonance imaging that has changed our lives. And so all sorts of opportunities.
All right, we never know when that next great discovery is just right around the corner, so this is pretty exciting stuff. Dr. Fall, last week, the DOE announced the launch of the Energy Storage Grand Challenge, a comprehensive program that builds on the administration's Advanced Energy Storage Initiative to accelerate the development, commercialization, and the utilization of next-generation energy storage, the technologies that will sustain American global leadership in that particular area. As director of this Office of Science, what will you do to support and help make sure we maintain these initiatives?
Thank you for the question. It is a huge opportunity. As we know, there's a phenomenally good penetration of renewables in our country, wind, solar, others. The Achilles heel is grid-scale storage, and so that's why not just the Office of Science, but the Secretary has directed the whole of the Department of Energy. This Grand Challenge is a whole-of-department initiative, including NNSA partially. They have less of a role, but the applied offices and, of course, the Office of Science, where we do the fundamental work on batteries, characterizing batteries for one, materials, basic material science that feeds into the applied side for for batteries and other modalities as well. So we're participating fully. Again, it's a whole of department effort at a very high level. This has the personal attention of the Secretary.
Real quick, in the time I have left, in your opinion, pardon me, what basic research programs in the Office of Science are the most essential to the development of that next generation energy storage technology?
Typically, energy technologies in general are a materials science problem. Critical materials and material science, that's what leads to a lot of advances in all sorts of advanced energy technologies.
Okay. Thank you, sir. And Madam Chair, I yield back.
Thank you, Mr. Weber. I'll now recognize Mr. Lipinski for 5 minutes.